Hello, everyone, and welcome back to week 2 of Caleb's Corner. Oh, that's terrible. What a bad name. Surprised I even got a week 2. No, not kidding. So last week I talked about, well, first of all, I'm Caleb Adcock. I am the quality software manager for Texas Quality Assurance. Last week I talked about becoming a certified welding inspector. So if there's any of you listeners who are in quality, maybe you're an inspector currently, or even a quality manager, and you just want to kind of establish yourself or, polish up your welding experience, definitely certified welding inspector is a nice venture to help do that. Very, very complex, very hard to do. Which is why I put out last week's episode to kind of help some people out who may be thinking about that. But it's worth it, and it will ensure that you know everything you need to know about welding. So this week I was going through doing the working on the app that we're about to deploy. So we have TQA Cloud right now, which is it's based off of SharePoint. It's a web-based app, and we've got all kinds of modules for quality management. Kyle and I say that we created this because it's what we needed, and then we found out that's what everybody needed, and so now we give it to everyone. So anyway, there's calibration and maintenance part of it. There's the data part of it. There's the employee and training part of it. So what I'm working on doing right now is actually building an app. So it'll be more of like an app type experience where it's just kind of seamless. You go from one part to the other rather than like the web page type version. The app actually lets you kind of tie in a lot of the different data connections so that you can reference different things. It's kind of hard to explain without showing it, but one of the things that I am constantly facing, and I'm assuming it's more as a software developer or software engineer than it is as like a mechanical engineer. But the concept of iterative design versus like radical redesign. So what I mean by this, so let's say that you've got a goal that you're trying to accomplish. So you get your idea together and, you implement your plan and you build it and you try it and it kind of works. And you're like, okay, well, that worked a little bit. So let's tweak this. That worked a little better. We're still not quite there. Okay, let's do one more tweak. So at what point do you just say, hey, the approach is all wrong? That would be the radical redesign portion, and then the little minor tweaks would be like the iterative design. So I was like, all right, well, actually I didn't even know the name of it. I understood the concept. I was like, okay, there's times whenever I just completely have to redo something. I'm like, scrap it. It's not usually a great thing to do, but whenever you're like, especially with software, because you essentially can do whatever you want with software. Somebody compared us to wizards. We can create stuff out of nothing essentially. You can do whatever your imagination, but it's the same way with like fabrication and stuff. But it's like sometimes you get an idea and you try something and it's just way off base and you're like, holy cow. And you're learning about the problem as you're trying to solve it. And, as you gather more information, you're like, well, this different approach, or, maybe you start to learn about what the future of the, uh, taking the problem further. So you're like, all right, well, later on down the road, we're going to run into this. That's not good. So, that might be an aspect of like, all right, well, I got to scrap it, rebuild the foundation and start over versus we're almost there, tweak it. We're almost there, tweak it. We're almost there, tweak it. So yeah, I was like, I tried to explain that. I use like ChatGPT because it's a lot easier to just like explain things and like Google, because you never know if you're not even saying the right thing with Google. So ChatGPT is really good at like, all right, it's like, I don't know what you're talking about. So you give it more information. It's like, okay. So that's where it's like, okay, that's radical redesign versus iterative design. So, and the reason that I was like, okay, well, I could talk about that is because that process, is also with any system that you design. Let's say that you're a quality manager, and let's say that you design a test, right? And it's probably going to involve engineering and stuff like that. But let's say that you're trying to test for something. So you're doing these quality tests, let's say you're doing non-destructive testing on your welds, and you're doing some stuff, and everything's passing the test, but then you're sending out this product and you're having issues in the field whenever it's actually being put to use. And it's kind of the same way with software. It's like you design something, you use it as a user, how it's designed, you're biased, so you're subconsciously clicking things that is going to work. But as soon as you let somebody else try it, or in the case of manufacturing, as soon as it gets out into the field, it starts having issues. So you need to redesign your approach to testing that product. So here's again where it comes in. Okay, well, do we slightly tweak? All right, well, maybe we need to take this measurement, or maybe we need to do eddy current instead of, whatever, ultrasonic, or, something like that. So you're like, okay, well, let's say you do that, you're still having issues. Or let's say you do that and you don't find anything. That kind of tells you right there, well, something's going on. I didn't find anything. So that's going to tell you immediately. So how many different processes do you keep trying versus, when you just finally say, well, it's time to do some destructive testing, like we're going to put this thing in field conditions, and, we got to do what they call destructive testing. It's essentially where, you use the product until failure. This could be, tensile strength, that kind of thing, where they stretch the metal. But that's what I'm talking about. And, if you start looking for these kind of things, especially if you're a systems designer, and, I'm sure a lot of you are probably already familiar, like, yep, I know what you're talking about, or, oh, yeah, I know about that. That's easy. That's probably more the case. But yeah, for me, it's like, I think the only way that you can make those calls is experience, and let's see, I was a welding inspector for a long time, certified welding inspector for a long time, and even as you're doing that, it's like you're learning about, okay, here's why I'm testing what I'm testing. Here's, why the person who came up with the inspection test plan did it this way. You start to understand those things. So you do start to, I don't want to get myself in any trouble here. Always go by the code and all that kind of thing. But you do start to understand, the spirit of things. So what I was getting at is, like, I think experience brings about that idea of, like, okay, when do I just scrap something, rebuild it from the foundation, or just keep tweaking it? Just, that kind of thing. And I was like, okay, well, where were some examples of this? Obviously, anybody that follows news follows SpaceX. Apparently, whenever they were redoing the Raptor engines, whenever they finally decided to go outside of Earth's orbit, and the whole Mars thing, I think the old engine was called the Merlin. And I don't even know if maybe it was the whole spacecraft or something like that. No, it had to have been an engine. But anyway, it's called the Merlin. It used a fuel called RP1. And that's what it was designed on. And that's what it knew. And they approached the problem of going to Mars or going to the moon or whatever, and like, hey, we need something else to get us out of orbit. It's a whole different thing, getting up into orbit versus getting out of orbit. So they switched, I believe, to methane, which is apparently way more complex. They had to change a bunch of things, but somebody had to make that call of, like, no, we're not going to keep tweaking this rocket using the same fuel in order to try and get out of orbit. They understood that they're gonna have to step outside of that, essentially. Or, like when I was talking about with coding, it's like you start to understand the problem and you start to foresee things in the future, and you're like, nah, this isn't gonna scale, I guess is the proper term, to, it's not gonna scale to the changes. So they switched over to the methane. We've talked about Boeing. And one of the things, I'm cheating here just because there's all these acronyms. I can't even remember like what I just said. But one of the things that they did was they switched the engine in their 737s. Okay, so what that did was it switched the center of gravity of their planes. So, the center of gravity is a big thing with aircraft and airframe and that kind of airworthiness. That is a big deal. Like, that's one of your pre-flight check requirements you have to have is a calculation, weight and balance calculations. Big deal. You have to understand that with your aircraft because it affects your flight characteristics. So what they did was whenever they, redesigned this engine for the 737 MAX, they realized that changed the center of gravity, and they're like, well, crap. Like we call it, in welding, I guess you'd call it an essential variable, because once you change that center of gravity, it handles differently. So you then have to start going into training your pilots, because now you're essentially flying a different aircraft. It's not handling the same. You got to start recertifying. Well, Boeing was like, what if we designed this MCAS, which is like essentially an automated control that makes the plane act like the old 737. So what it's doing is so the center of gravity changed, the plane's flying differently. However, there's this automated control that's forcing the plane to fly how it used to. So the pilot's getting the same experience as the old 737s. So they decided they're not going to change the whole airframe. They're not going to change the whole plane. They're just going to add a system in that, gives the pilot the ability to fly just how they normally would. However, that didn't end up going well, because they started having issues with that MCAS, and that's where, and I don't remember the specific flight numbers. I think one of the instances was one was east of Houston, and then I think that may have been the same one that was in Louisiana. It was like they landed in a marsh. But what was happening was the pilots were fighting that system. The system kind of messed up, and the pilots were they weren't trained properly on the system apparently. And the thing, you heard about where the plane was diving, but it was trying to pull up, but the pilot wasn't anyway. So that ended up being where the pilot was fighting the system, stalled the plane out, crashed the plane. That's one of the ways where the iterative design maybe should have just been, we just need to build a different plane instead of, putting these engines into these old, the old airframes or whatever. So, that's kind of one of the scenarios that I was looking into. But yeah, it's like I said, I think for me personally, it's just come with experience. When I've learned like a ton with the platform that we use, Power Apps, for the app that we make. And, it's a Microsoft thing. It's essentially, I'm an expert. I am an expert in Power Apps, but, you're always learning with these kind of things. And I think that with that, with that experience comes the ability to make those decisions, and okay, when do we just keep tweaking versus when do we redesign? And sometimes that decision doesn't come until the very end. Maybe you've put all the little pieces together and you've tweaked all the little minor pieces, but then you get to the very end and the whole end experience doesn't work. That's not good. So, you kind of want to test your end result as quick as you can, and you want to keep that in mind. I think that's some of the shortcuts that we're able to take with material testing, with the welding and stuff like that. And, weld engineers, they're the ones that generally have to deal with that kind of thing. But, it's like you don't have to completely build the part in order to be able to do tensile tests or stuff, for certain welds. So I think that's pretty much the concept. I didn't find anything definitive. I'm sure there's whole books on where people, in this situation, it's better to scrap it and just do a redesign versus iterative design. I'm sure there's books out there. Maybe I'll find one. But just on my quick search of the internet, it's essentially just came down to, whatever your experience is, and just really do your due diligence and trying to make the best educated decision, which is, all we can do. So anyway, if you got any questions or comments, maybe you've got your own experiences with this or your own advice, I'd love to hear it, because like I said, I'm still learning. But yeah, let me know.